there's nothing actually being canceled there. Friction opposes the direction that it's sliding.
Yeah.
So they are in opposite directions. They don't cancel because one's velocity and one's a force or acceleration. They are not the same quantity. Canceling happens if they were two forces, yeah, they can cancel.
Mm-hmm.
If I got two of any vector of the same quantity in opposite directions, yes, it's called canceling. But the friction acts against the velocity. It doesn't like what you're doing. And I say that, I can think of exceptions, so.
Well, can I try to word it better?
Okay.
It'd be the opposite direction it's going.
Friction will act opposite the direction it wants to go.
Yeah.
So if we see
Which if it actually is moving, then yes, it's the way it's moving.
Okay.
if we see friction in one of these problems like this, is it safe to assume that it would always be positive where there is friction?
No. It's always safe to say that it's opposite the velocity.
Okay.
Because if there was friction on the bottom, it would be negative, right? Like if you had friction between.
If I had friction in right here, yes.
It'd be negative.
It'd be negative when the box is going this way, friction would be positive when the box is going the other
Yeah,
way.
because the box is on the bottom, it's moving this way, and friction is acting this way.
Because it would be opposite
So it'd
of
be the
velocity.
opposite of the direction of the box. It'd be negative.
Yes,
Because it's moving in the positive direction.
yes,
Okay.
that I'll go with.
All right.
And at the risk of messing things up here, if you got it in your head, the fact that I have A and B written down below doesn't mean it's actually traveling on the bottom, it's just.
Well, that's how I look at it.
Okay, all right,
I mean, I know it's technically not, but it's just how I look at it.
then I will move on. All right, I wanna get back to what Emily said. In essence, I'm gonna break it down slightly. If you're decelerating, which doesn't necessarily mean positive vector acceleration or negative vector acceleration, this means that your speed is getting smaller. So if you're decelerating, so if your speed is shrinking, and the velocity is positive, it would be negative acceleration, vector acceleration. If velocity is negative, I think it would work if you think about in terms of how's the speed changing, and take that sign and multiply it times the sign of the velocity. I know I use slightly different language, but I don't want someone to come back and say, but you said, and because I was using imprecise language. But I think it would work. All right, you will think you had a question?
Yeah, this is a woman who's lifting weights, and then we're asked to draw the position this time, velocity this time, and acceleration this time.
Which one? That we're asked to draw it? Oh, that was,
The position, the velocity.
all right, so we got the 100-pound woman starts her daily lifting of weights. She stands on the floor, pulls the weight up to her waist, puts them back down when the weights are off the ground. Okay. And so this is just the,
Position, velocity.
all right, so presumably of the weights, or we'll say just.
Of the weights being lifted.
Okay. All right, so I'm taking an object here. So basically what's happening here is that the weight's on the ground. She bends over, grabs them, lifts them up, and then puts them back down. So position is just basically, you think about the motion of the position right there and just stretch it out over time. So position versus time, the weights start on the ground. Doesn't really matter how long it's on the ground here, but starts on the ground, they lift up. Do I state that she holds them there, or she just goes up and then down? Okay, so if she's just going up and down, so as you pick it up, it starts at rest, and so she has to build up speed and then slow it down again. So in essence, what's happening here is something like that. Or actually, since she has to pick up speed, something like that. Yeah, the way that you have it drawn there with a sharp peak is, she's still speeding up when she gets here, and then all of a sudden, it goes through some sort of rip in the space-time continuum and starts going the other way. Okay, if you're trying to do reality, avoid the sharp points. Now, if you have a different position time graph, then your velocity time and acceleration time will be based upon that. So it's possible you just botch the first one and get the other two completely right, because given the previous. So now, velocity time. I know the velocity starts out at 0. And it's 0 at the peak, because that's the turnaround point. Between here and here, it's positive. Between here and here, it's negative. So I have to go from 0 to here, and then something like that. And then acceleration time. Again, thinking about the slopes here, this is the point when the velocity changes from.
Wait a minute, you said it's positive on the left side, so wouldn't it be like this?
Yes it is, I have that upside down. Thank you. There we go, thank you. And I know acceleration is the slope of the velocity graph, and so I know it's 0 here, I know it's 0 here. It's negative in between them, so let's actually take the zeros down first. It's negative in between them and positive on each side. So the way I have it there, oh, that bit right there. And actually the way I've drawn it here, it's 0 there and there. Something like that, given the way I've drawn this. It's quite possible that in the solution, I had it doing this instead of coming back down to 0. This, the way I've drawn this one is she grabs it, she picks it up and puts it back down, done. If she's just constantly moving up and down, so there's not this rest period in between the way I've drawn it, because I was projecting myself onto this, then this would be looking more like that. And for you math fans, inverse cosine curve, positive sine curve, cosine curve.
Can you explain the last one you drew? That one doesn't make sense to me.
All right, there are two scenarios that I laid out there. One where she picks it up, puts it down, and there's rest period in between, or the one where she's just constantly moving up and down. Which one do you want?
She rests.
Okay. So the velocity would look something like that. So it starts out at rest, she moves it upwards, she's hitting her maximum speed somewhere in the middle, and then when she gets closer to putting it on the ground, it stops for a moment. She's not resting in between lifting it up. Sorry, starts, she lifts it up, and as soon as she gets to her waist, she starts going back down again. The acceleration is the slope of this. And so, and a zero slope is one that's horizontal. So it's horizontal here, then it gets steeper and steeper and steeper. It's horizontal again, then negative steep, 0 again, and then 0 again. So it's 0 at the beginning, it's 0 there, there, and there. in this first region, that's where she starts moving it up. It's positive velocity, or sorry, a positive slope. It's positive velocity this entire time here, but it's positive slope there. And so acceleration's gotta be positive. Then my slope is negative, and then my slope is positive again.
So that one makes sense to me. Why is it that way over there?
All right,
That's what didn't make sense.
that scenario right there where it goes up like that, that is, she's constantly moving up and down. She only stops very briefly.
Okay.
That's the difference between them.
Okay, got it. Thank
Okay.
you.
Okay, after that second, trough at the bottom, would you keep drawing if you're,
For any of them?
for this middle graph? After the lowest point, would you keep drawing back up?
If it's constantly up and down, then this graph would be doing a very similar.
But I don't think the question is like that. So if she just made it to the bottom, she stopped, did you stop drawing at that point?
Yeah, I stopped drawing there.
Okay.
This is just, because the original drawing I had in red here was that she just does one cycle, one rep, one thing of it. I guess one rep. Okay, thank you.
Can
Right.
you explain the acceleration versus time again, like how you get the acceleration from the velocity?
How you, from the slope. So, is it the question of how this is acceleration here? How do you get this from this, or why does the thing go up and not come back
Just like
down?
why, cause the velocity, it looks like it goes up and then it stops, but, in the acceleration, it goes down.
Acceleration deals with change in velocity. So at this point right here, my velocity is 0, and then it starts to become more and more positive. So, well, better drawing over here. So we're starting out at 0 and we're staying there. Then she walks over, she grabs it, and then starts to move. So the acceleration starts to move. And so my velocity changes quickest here. At this point, she's gonna start to slow down because she's reaching that stopping point. So at that point, she's still moving upwards, but at less and less change. So actually, that's about the midpoint. So as you're lifting it, all right, I got the bottom here, top here. So this is the point where it turns around. So this is the point when I was scratched down. This is the point when I get to my waist. This is the point about halfway in between when I've hit that maximum speed as I'm moving up. Once I get past that one, my velocity starts to decrease.
Yeah, cause you slow so you can stop.
And so at that point right there, my velocity is positive because I'm still moving up, and I'm slowing down, so my acceleration becomes negative.
So down here, so that whole curve is just one lift up?
Yeah, this is just one lift.
Like you don't go back down, this is just like one.
Oh, no, sorry. The lift, for position time, that's where the lift, that's the waist. This is when
Yeah.
she's at the waist.
And it's the
That's the word waist. Here, this is the point when you're at the waist. And here, that's the point where you're at the waist.
Okay, so why does she take that long to slow down?
Take the long slow down. Oh,
Like she lifts it and like the acceleration is increasing and then it decreases some.
it's a question of why is that so much bigger than this is?
Well, why does it cross through the origin and then why is that so much bigger? So both of it.
This point right here is, all right, let's do numbers. So I start out at 0, these are my velocities. And then 1, 2, 3, 4, 3, 2, 1, 0. So let's assume that these are meters per second, whatever units you want to use. So on the ground, speeding up and then slowing down, this is the point, this is turnaround at the waist.
Okay, so as she slows down as she gets to the waist,
I would hope so.
and then she goes down at the waist?
Yeah, so she picks up speed, hits some maximum speed, but then she has to slow down in order for this thing to stop,
Okay.
however high she wants to lift it. So it stops briefly as it turns around and starts to go back down again.
Okay.
So the acceleration is 0. It crosses the origin here at this point when she starts, so she's getting faster and faster and faster, and then she starts slowing down. This is the transition from positive change to negative change.
Okay, so the 0 at the bottom is at her waist.
Yes.
Okay.
All right. So
And
your
then
question is,
that 0 is where you drew that line down?
that, so this 0 right here is that 0 right there.
Okay.
And it's just still accelerating because she comes back to her waist and then she immediately goes back down. The way that it was set up, I think Bill Hahn said she's not stopping, not holding it at her waist. It just comes up and then immediately back down.
Okay, so for the bottom graph, she gets to her waist, at like the first line that doesn't cross the origin, so like right there where you're pointing, it gets to her waist and then she goes back down.
She's at her waist here.
So what is the first one that it crosses the origin at? Oh, when it's.
That's the point in which she transitions from speeding up to slowing down.
Okay,
That's this point right here. That's when she hits her maximum velocity or maximum speed upwards. I feel like you're unsatisfied with where we've gotten to.
I just don't understand why, like, on the top part of the graph, why, like, there's a bump, but she's not slowing down. Like, her acceleration is going down, but she's not slowing down yet.
She starts slowing down at this point.
Yeah, so why does the graph curve, like, upward and then down before it hits that point?
Because she speeds up and then slows down.
Yeah, but the slowing down doesn't start at the little top of the thing.
This is my velocity graph, and this is my acceleration graph. This point right here is the point where she transitions from speeding up to slowing down.
Okay, but in the acceleration graph, it starts curving down before it hits that point.
Right, but the acceleration is positive here and the velocity is positive here. She's still speeding up until she gets to here. This is all speeding up, but she is speeding up more rapidly in this part than she is in this part.
Okay. Okay. But if she's speeding up less rapidly than she's slowing,
Say it again?
if she's speeding up less rapidly, doesn't that mean that she's slowing?
No, if you're going 50, if you start out in your driveway and you're about to take off, so you start out at 0, and then you slam your foot down on the brake, and don't go anywhere. You slam your foot down on the gas pedal, and you go get to 10 miles per hour, 20 miles per hour. As you get closer to cruising speed, you take your foot off the gas a little bit. You're not accelerating as quickly. Your velocity's not changing as quickly, but you're still getting faster, because then maybe you're going from 10 to 20 to 25 to 26, 27. You're still getting faster, just not as rapid a rate.
Okay. That makes sense.
That's what's happening here.
Okay.
I need help with the average speed and the distance traveled. So the problem says a car goes from negative 60 miles per second to 0 miles per second in 10 seconds. What is the average acceleration? You do the change in speed, which is 60 divided by 10, you get 6.
Change in velocity.
It says average acceleration. And the answer is 6.
Right, you're going from negative 60 to 0, so your change is positive 60.
Yeah.
Divided by,
The time interval,
right,
which is 10, so you get 6.
right.
Okay, then it says, for that problem, what is the average speed for the first 10 seconds? How do you do that?
How do you
All
get
right.
average speed?
In that particular problem, you're not turning around, because you start out at negative 60 meters per second, So you're going in the negative direction to start with.
So you're in a straight line,
Yeah, not only in a straight line, but you don't turn around.
okay.
So later years, I have them turning around to make it more interesting. But in that case, you're not turning around, so you're just basically going in one direction and stopping
Uh-huh.
in the problem. So since you're only going in one direction, the distance traveled is just the magnitude of your displacement.
So,
It was 10 seconds going from negative 60 to 0.
yeah. So the first question is asking the average acceleration, the second is asking the average speed, and then the last question is saying, how far did it travel in the first 10 seconds?
Yeah, all right, so again, not turning around. So what is your average velocity?
60.
Average. That's negative 60 is your initial velocity, 0 is your final velocity,
So, negative 30?
negative 30.
Wait, what?
Because
Is
that's
that-
where it's the 2, you 0 plus negative 60,
And-
divided by 2.
That's average velocity.
Yeah,
Is negative 30.
yes.
So that's not average speed?
No, there's a negative sign, speed's a scalar.
So you would just cover up the negative sign and be 30?
So if I ask for average speed, then yeah, it'd be 30.
So how did you get that again? I'm sorry. How did you
All
get
right.
30?
Or 0?
And again, this works because you're not turning around. If you're turning around, it
Yes.
becomes more complicated.
Because it says flat road.
Yeah,
I'm guessing that's the indicator of they're not turning around when they say flat road.
no, the fact that they're not turning around is the fact that the problem ends at 0.
0, okay.
So when you're averaging, you add up, just classic averaging, you add up the number of numbers you have and divide by however many you just added up.
Oh, well, can you just do 60 divided by 2? Because 60 plus 0
Divided by
by
2.
2 and you get 30. So
Yeah.
that's your average velocity. But for average speed, that's not a negative number, it's 30.
Yes.
Okay, so with the distance.
So let's talk again about displacement. So the displacement, I'm going on average negative 30 meters per second for 10 seconds. So what's my displacement? If it's on average negative 30 for 10,
300
this,
meters per second. Meters.
it would be meters. Negative